Class 11th Chemistry, Unit 4, Chemical Bonding and Molecular Structure, and in this video we will discuss about ionic or electrovalent bond and lattice enthalpy. First come to ionic or electrovalent bond. Cosell drew attention to the following facts. In the periodic table, the highly electronegative halogens and the highly electropositive alkali metals are separated by the noble gases. The formation of a negative ion from a halogen atom and a positive ion from an alkali metal atom is associated with the gain and loss of an electron by the respective atoms. It means halogen atom gain electron and form negative ion, and alkali metal atom lose electron and form positive ion. The negative and positive ions thus formed attain stable noble gas electronic configuration. The noble gases have a particularly stable outer shell configuration of 8 electrons, and this presence of 8 electrons in the outer shell is known as octet. This is NS2 and P6. But helium is exception. Helium has a duplet of electrons. Okay. The negative and positive ions are stabilized by electrostatic attraction. Now let us see some examples. First one is the formation of sodium chloride, NaCl. Na with electronic configuration Ne. This is closed shell. Outermost shell is 3s1. It lost one electron and convert into Na plus ion. And this Na plus ion has electronic configuration similar to noble gas neon. Chlorine get one electron, convert into Cl minus ion. Again, this chloride ion has electronic configuration similar to noble gas argon. Na plus ion and Cl minus ion attract together and form ionic compound NaCl. Another example is formation of calcium fluoride. Calcium electronic configuration Ar4s2 loses 2 electron and convert into Ca2 plus ion, and this Ca2 plus ion has electronic configuration similar to noble gas argon. Fluorine gain 1 electron and convert into F minus ion, and again this fluoride ion has electronic configuration similar to neon. Ca2 plus and 2F minus attract and form CaF2 ionic compound, calcium fluoride. Okay. The bond formed as a result of the electrostatic attraction between the positive and negative ions is termed as the electrovalent bond. The electrovalency is equal to the number of unit charge or charges on the ion. Thus, calcium is assigned a positive electrovalency of 2, while chlorine a negative electrovalency of 1. Simply we can say the charge present on the ions gives the electrovalency. You can see the formation of ionic bond. This is Kate and dog. Kate lost its piece of bond and dog take this piece of bond. Okay, losing and gaining, representing formation of ionic bond. The formation of ionic bond would depend upon the ease of formation of the positive and negative ions from the respective neutral atoms, and the arrangement of positive and negative ions in the solid, that is the lattice of the crystalline compound. Metal in the gaseous state lose one electron, convert into gaseous metal ion and whatever the energy required for this process, that is known as ionization enthalpy. This is non-metal. Gain electron convert into negatively charged ion, and whatever the change in heat or energy is taking place in this process, that is known as electron gain enthalpy. This positive ion in the gaseous state and negative ion in the gaseous state combined by the force of attraction and form this Mx solid, and whatever the change in heat taking place in this process, that is known as lattice enthalpy. Okay, and we already discussed that is metals have low ionization enthalpy and non-metals have high negative electron gain enthalpy. Okay, that's why ionic bond will be formed more easily, more easily between elements with comparatively low ionization enthalpies and elements with comparatively high negative value of electron gain enthalpy. And in this formation of ionic compound, lattice enthalpy plays a key role in the formation of ionic compounds. Now, what is this lattice enthalpy? Lattice enthalpy of an ionic solid is defined as the energy required to completely separate 1 mole of a solid ionic compound into gaseous constituent ion. Clear? 1 mole of solid ionic compound into gaseous constituent ion. Whatever the energy required, that is known as lattice enthalpy. For example, the lattice enthalpy of sodium chloride is 788 kilojoules per mole. This means that 788 kilojoules of energy is required to separate 1 mole of solid NaCl into 1 mole of Na plus gas and 1 mole of Cl minus gas to an infinite distance. And this process can be represented like NaCl solid, it will convert into Na plus gas and Cl minus gas. Whatever the energy required in this process, that is known as lattice enthalpy. Okay, we can also say like this: when 1 mole of Na plus gas and 1 mole of Cl minus gas convert into NaCl solid, which is 1 mole, energy release, that is known as lattice enthalpy. Okay, the solid crystal being three-dimensional, it is not possible to calculate lattice enthalpy directly from the interaction of forces of attraction and repulsion only. It is determined indirectly using Born-Haber cycle. And about this cycle we will discuss in the chapter thermodynamics. Okay student, thank you.